Welcome back to Advanced Functions. This is a new chapter called Irrational Functions. In this lesson number 1, we are going to explore the graphs of reciprocal functions. So we're going to get familiar with graphing different types of reciprocal functions of either a linear or a quadratic functions. Now, there are some general rules that you have to remember before graphing. First, we have to assume that the given function f at x, and the reciprocal function is going to be a continuous function. Okay. Now, keep in mind that, so here are some general rules. If my original function is greater than 0, meaning above the x-axis, then my reciprocal function will also be above the x-axis as well. Okay, but if my original is less than 0, that means my reciprocal will also be below the x-axis. Second rule is that if the given function, my original function, is even, odd, or neither, then the reciprocal function will also follow exactly the type of whether it's even, odd, or neither. So they are they are exactly the same. Number 3, if the function, my original function, is increasing, then my reciprocal function is going to be decreasing. Okay, so this is a key rule to remember when you're graphing it. So if my original function is, let's say it's decreasing, then that means reciprocal is going to be increasing over the same interval. Okay, so they're going to be opposite. The fourth rule is that if my original function has a global or local maximum minimum at this point, that means my reciprocal function will also have a global or local maximum minimum at a same point, but make sure you reciprocate the y value. So it's going to be 1 over f at a. Okay, so keep in mind that if you find that there is a turning point, that means my reciprocal function will also have a turning point at that area. Okay, but just keep that in mind, the y is flipped. The fifth rule is that if I have a horizontal asymptote for my original function, then the reciprocal function also has a horizontal asymptote when you flip that y value. Okay. Next, if the function is unbounded means y will be increasing towards the infinity or negative infinity, then the reciprocal function, it's going to have a horizontal asymptote at y is equal to 0. Now, another way to remember this rule is that for my original function, let's say y is equal to f at x, if my original function is, the degree is, let's say this is the numerator degree and this is a denominator degree. If my numerator has less than, so numerator is less than the denominator degree, that means you're always going to have a horizontal asymptote and y is equal to 0. Okay, so always keep that in mind. So for example, if I have y is equal to 1 over x minus 2, the degree for the numerator is 0. Okay, and the degree for the denominator is 1. So therefore, because I have a higher degree in the denominator, you will have a horizontal asymptote, y is equal to 0. Okay. If the degree is the same, then we are going to explore that later. But for example, let's say y is equal to 3x and then x minus 2. Now the degree at the top is going to be 1 and the degree in the denominator is 1. So if it's same, then you look at the coefficient of the degree. So in this case, my horizontal asymptote is going to be y is equal to 3 over 1, which is 3. Okay, so we will talk about this more in detail in the next lesson. Now the seventh rule is that if I have x-intercept for my original function, then my reciprocal function, that is going to turn it into a vertical asymptote at x is equal to 0. Okay. And then lastly, if I have a function have a vertical asymptote, that means my reciprocal function, it's actually going to approach 0. Okay, so let me show you what I mean by number 8 rule. Now, given question 1, so you're given a function. So I see two types of function. The first one is the linear function over here. Okay, and I have a second type of function, which is a parabola. Now, use the general rules that we just learned to graph the reciprocal function from a given function. So first things first is what I would do is identify any x-intercepts. Why? Because the x-intercept is going to turn it into a vertical asymptote. So I have over here, I have x-intercept over here and over here. Now, my reciprocal function, it's going to have a vertical asymptote at the x-intercept. So I'm going to draw a straight vertical line. So this is my vertical asymptote at x equals negative 2.1, let's say. And then I have a vertical asymptote at x equals 0. And it looks like I have another vertical asymptote at about 2.1, let's say. So that's a line that my reciprocal function will never touch. Okay, now, so the second thing is that it looks like my graph, let's assume that it looks like at 1, there is a asymptote, a vertical asymptote. Okay, so it's a slight, assuming that this straight line is going to approach negative 1, but it will never touch negative 1. Okay, let's just assume that. So that means at the vertical asymptote of my original function, my reciprocal is going to approach 0. So at negative 1, I'm going to draw an open circle. Okay. Now let's see. So let's move from left to right. From the left side of my function, so let me highlight this component over here. Okay, so it's above the x-axis. So that means my reciprocal function is going to be above the x-axis as well. And another thing to note is that it's decreasing. So my reciprocal is going to be opposite. If it's decreasing, it's going to increase. So therefore, and we already know that it's going to be increasing like this. So it's not going to touch the asymptote, but it's going to approach it. And we have a horizontal asymptote over here. Okay, next thing, let's take a look at this graph. From here, it looks like my graph is below the x-axis, meaning my reciprocal is going to be below the x-axis as well. Again, it's decreasing. So my reciprocal is going to be increasing. So if it's increasing, that means I have to graph this way. It's increasing like this. Okay. Next, I have a graph that is above the x-axis over here. Okay. That means my reciprocal will also be above the x-axis. But unfortunately for this one, it's decreasing. So then reciprocal is going to be opposite, meaning it's going to increase. So therefore, it's going to turn it like this and approaching the asymptote. So it looks like we have a cubic function. Okay. Next, we have a graph over here. It's below the x-axis. Okay. Now, another thing to keep in mind is that if you have a maximum or minimum, at that point, you're also going to have a maximum or minimum for the reciprocal function as well. Okay. So we have our minimum at, let's see, -1, -2. So at the same x, instead, you're going to flip the y value. So it's going to be 1, it's going to be -1/2 because it's reciprocal. So it looks like I have my same point. So if this is a minimum, then it's going to be a maximum for my reciprocal. And so from 0 to 1, the graph is below and it's decreasing. So that means my reciprocal is going to be below the x-axis, but it's increasing. So therefore, it's going to be like this. It's increasing. Now, from 1 to 2, you will notice that it's below the x-axis and it's increasing. So for reciprocal, it's below the x-axis, which is the same thing, but it's going to decrease. So it's going to decrease and approaching the asymptote. And lastly, anything after 2.1, it's increasing. So my reciprocal function is going to decrease, but above the x-axis. So it will look something like this. Okay, so therefore the blue graph I just drew is going to be y is equal to 1/f at x. And the red one is the original function. Okay. Now let's try the next graph. So we are given a function f at x, 2x minus 4. So we're given a linear function. And it wants us to draw the reciprocal function on the same grid. Okay, so let's just assume that we have a grid over here. Okay. Let's see, this is x, this is y. Now 2x minus 4. So let's see. I have a y-intercept at -4, 2, 3. So let's just say that this is at -4. So we have my y-intercept, and the slope is 2, so it's going to be, this is 1, 2, so we have a line here, and it's going to be a straight linear graph. My apologies, it's not very straight. So that is my f at x. Okay, now let's draw a reciprocal. Now to do a reciprocal, keep that in mind. For x-intercept, it's going to turn it into a vertical asymptote. That's your first step. So I'm going to draw a vertical asymptote. So x is equal to 2. And then we know that, so let's read from left to right. So we already know that we are going to have a horizontal asymptote because the denominator degree is bigger than numerator. Okay, so we do have a horizontal asymptote at y is equal to 0. Now, from -infinity to up until 2, it's below the x-axis and the graph is increasing. So that means if it's increasing, for reciprocal, it's going to be opposite. It's going to decrease, which is below the x-axis. So it's going to look something like this. Okay. Now, after the vertical asymptote at 2, so my original graph, it's above the x-axis and it's increasing. So my reciprocal is going to be, again, above the x-axis, but it's going to decrease, which is the opposite of the direction. So therefore, above the x-axis, but decreasing. So it's going to be something like this. Okay, so therefore the green one is going to be g of x. Okay. Next, so now this time we are given f at x. So it looks like we have a quadratic function with a degree of 2. And they want us to draw a reciprocal function of that. Okay, so same thing. Let's draw the grid. Let's say we have a grid over here. Okay, my apologies if the lines are not very straight. So this is x and this is y-axis. Now let's label so because it's a quadratic, I'm going to draw the zeros. It looks like we're given the zeros at 1. So at 1. And we have zeros at -2. And as you can see, it's a open graph because my leading coefficient, it's +1, 1x squared. But we don't know what the vertex is going to be. So what I'm going to do is I'm going to find the vertex, put it in a vertex form. So I'm going to open it up. So it's going to be x squared plus x minus 2. Complete the zeros. So it's going to be x plus 1 over 2 plus minus 9 over 4. Okay, so all I did was I found ways to complete the square by finding and put it in a vertex form. So it looks like my vertex is at -1/2, -9 over 2. So it's going to be somewhere above -1, -2. So if this is going to be -2, so it's somewhere over here. Okay, so this is -9 over 4. It's going to be something like this. Okay, so that is my f at x. Now we are going to draw the reciprocal. For reciprocal, first step as always, identify the x-intercepts, and that's where my vertical asymptote is going to be. So vertical asymptote, x equals -2, and I have another vertical asymptote at x is equal to 1. And I do also have a horizontal asymptote because the degree in the denominator is bigger than the numerator. So it's going to be y is equal to 0. Okay. Now, another thing is that when you have a maximum or minimum, that means I'm going to have a same maximum or minimum at that same x. So if I were to have maximum, so in this case, I have a minimum at -1 over 2, -9 over 4. My reciprocal is going to be a maximum at same x, but I'm going to flip it, -4 over 9. So it's going to be somewhere over here. So it's here. That is where -4 over 9 is going to be. Okay, now, so let's do left to right. So as you can see, before the -2, it's decreasing and above the x-axis. So that means my reciprocal is going to be above the x-axis, but instead it's going to increase. So it's going to be something like this. Okay. Again, so if this is a minimum, then you're going to have a maximum. Easy as that. So it's going to be this. and this. And after 1, it's increasing and above the x-axis. So it's going to be above the x-axis, but it's going to decrease. So it's going to be something like this. So the red one is going to be the reciprocal of my original function. Okay, next. So we are given a cubic function this time. So it's something different. Let's see. Now, if you're given just like an expanded standard form, the best thing is to identify if you could factor. So y is equal to x cubic minus x squared minus 2x. So let's do a common factor, x squared minus x minus 2. And then I could do a trinomial, x minus 2, x plus 1. So this way you will be able to identify the zeros much better. So let's draw the axis here and here. Okay, so this is y and x. And it looks like I have the zeros. So I will do the blue one. So I have zeros at 0, at 2, and at -1. Okay. Now, so for this one, I will be doing a number chart. So 0, -1, 0, and 2. So I'm going to plug in a number that is smaller than -2. So let's say -4. So I'm going to plug in -4 and see what my sign is. So -4 is negative, times -4 minus 2 is negative, and then -4 plus 1 is going to be negative. So negative times negative times negative is going to give me negative. Okay, now let's plug in a number that is in between -1 and 0. So let's see, negative 0.5. So negative 0.5 is negative. Negative 0.5 minus 2 is negative. Negative 0.5 plus 1 is going to be giving me a positive answer. So when I multiply this, it's going to give me a positive number. And then let's plug in a number that's in between 0 and 2, 1. So 1 is going to be positive. 1 minus 2 is going to be negative. And 1 plus 1 is going to be positive. So when I multiply all three signs, it's going to be negative. And let's plug in a number that's greater than 2. Let's say 3. 3 itself is positive. 3 minus 2 is going to be positive. 3 plus 1 is going to give me positive. So when you multiply, it's positive. So using this sign interval, I know anything before -1 is going to be down. Okay. And anything between -1 and 0, it's going to be positive above the x-axis. Okay, so it's going to be this. And then, oops, let's draw a little bit smoother. And then from 0 to 2, it's going to be negative. Okay, so because it's a polynomial. And then from anything after 2, it's going to be above the x-axis. So it's going to be that. Okay, so that is my f at x. So to do the reciprocal function, again, let's identify the x-intercept. It's going to be, that's where my vertical asymptote is going to be. So it seems like I have 3 vertical asymptotes because I have 3 x-intercepts. Okay, so vertical asymptote at x equals -1, x equals 0, and x is equal to 2. And again, I have a horizontal asymptote because my degree is bigger than the numerator. So my horizontal asymptote is y is equal to 0. Okay, now let's identify the maximum or minimum. So it looks like I have a maximum over here. So then that means I'm going to have a minimum at this flipped point. So 0 point, so if I were to flip one divided by, let's say, 0.5, it's going to be 2. So let's say here. And then at x equals 1, I have a minimum, so I'm going to have a maximum at this point. So flip this one, it's going to be -1. So let's say it's about here. Okay. Okay. Now let's see. So from anything before negative, it's below x-axis and it's increasing. So that means it's going to be decreasing below x-axis. It's going to be this. Okay. And then because we have a maximum over here, we're going to have a minimum, which is this way. And then over here, because we have a minimum, we are going to have a maximum, right? And you can double check as from 0 to your minimum, it's decreasing. So your reciprocal must be increasing, okay? And then after 2, it's increasing and above the x-axis. So my reciprocal must be decreasing and above the x-axis, which is this way, okay? So for the red one is going to be the reciprocal of g of x, which is 1 over f at x.